According to Einstein's theory of relativity, here's another example. Imagine a photon containing two light particles reflected by mirrors. One moving up and down, the other moving left and right. For a stationary observer, both particles will return to their starting point at the same time. But for a fast-moving alien, they will see the up and down moving photon travel in a triangular path, just like the light traveling between Earth and the Moon earlier. The left and right moving photon repeats part of its path, but the speed of light remains constant. Will the two photons return to their starting points at different times? Of course not. So, the horizontal distance must shorten, and only then will the two photons return to the start simultaneously. This is length contraction in relativity. It's the contraction of moving objects. Let's take another example. Suppose an alien meteor is heading toward Earth, and the alien spaceship, moving near light speed, experiences time dilation. So the alien sees the meteor moving slowly toward Earth. According to the law of conservation of momentum, the meteor's mass must increase, since momentum equals mass times velocity. To compensate for the slower speed, the meteor's mass must increase. So, from the alien's perspective, the meteor's mass has increased. This is the increase in mass for moving objects in relativity. Scientists have confirmed this in particle accelerators. When particles collide at 99.9% the speed of light, their mass is measured to be thousands of times greater. This confirms that relative mass increases. Now, suppose a rocket launches into space. According to Newtonian physics, it converts the chemical energy of fuel into kinetic energy. So the rocket gains speed. But according to relativity, the rocket's mass increases as it moves. So the rocket becomes heavier as it launches. Where does this extra mass come from? It must come from the energy used during launch. If energy can be converted to mass, it means mass can also be converted into energy. And that's how Einstein arrived at his famous equation, E equals mc. Energy equals mass times the speed of light squared. When an atom splits into two, the total mass of the two atoms is less than the original. The missing mass has been converted into energy, which matches the equation perfectly. That's why such tiny amounts of matter can produce enormous amounts of energy. Thus, time dilation, length contraction, and the increase of relative mass are the core principles of relativity. But do you know what really made Einstein famous?